The Mercator projection is a well-known type of map projection created by the Flemish cartographer Gerardus Mercator in 1569. This projection gained widespread popularity, especially in navigation, due to its unique ability to represent lines of constant compass direction, known as rhumb lines, as straight segments. By using the Mercator projection, sailors can plot a straight line course across the map to maintain a constant bearing, a crucial feature for maritime navigation. This functionality made the Mercator projection invaluable for explorers and travelers in the age of sea exploration. However, while ideal for navigation, the Mercator projection introduces significant distortions, particularly in the size and shape of land masses as they move away from the equator. In technical terms, the Mercator projection is a cylindrical map projection, which means it represents the Earth as if a cylinder were wrapped around the globe. Points on Earth's surface are projected onto the cylindrical surface, which is then unrolled to create a flat map. This process allows the Mercator projection to preserve angles and shapes of small objects accurately, a property known as conformality. Conformality makes this projection useful when accurate shape representation is necessary over small areas, as shapes retain their correct form. This preservation of angles is particularly helpful for navigational maps, where precise directional bearings are needed. However, the trade-off for preserving shape and direction is that it distorts area, especially for regions farther from the equator. The most notable distortion in the Mercator projection is its size exaggeration of regions at higher latitudes. Land masses closer to the poles appear much larger than they are in reality. For example, Greenland appears comparable in size to Africa on a Mercator map, though in reality, Africa is about 14 times larger. This distortion occurs because the Mercator projection expands distances north and south to maintain constant angles, which causes the spaces between lines of latitude to widen toward the poles. Consequently, while the projection maintains correct shapes for small areas, it sacrifices accuracy in the relative size of regions, particularly near the poles. Despite its distortions, the Mercator projection is widely used for various applications. Historically, its primary use was for navigation charts, where its ability to depict rhumb lines as straight lines simplified plotting a course. Today, it is also frequently used in online mapping platforms such as Google Maps. These platforms favor the Mercator projection because its grid structure allows for easy panning and zooming, especially in regions near the equator, where distortions are less extreme. However, the projection's tendency to distort size has raised criticisms, especially when it is used to represent the entire world, as it can create misleading perceptions of the relative size of continents and countries. The criticisms of the Mercator projection primarily center on its distortion of land area, which often results in a Eurocentric bias. Countries and continents near the poles, such as Europe and North America, appear much larger than those closer to the equator, like Africa and South America. This skewed depiction can lead to misconceptions about the importance or size of different parts of the world, and some have argued that it reinforces a biased perspective. In response to these criticisms, cartographers have developed alternative projections that aim to provide a more accurate view of the world. For example, the Gall-Peters projection is an equal area projection that preserves the relative size of regions, though it sacrifices shape accuracy. The Robinson projection offers a compromise between size and shape distortion, creating a visually balanced map that minimizes extreme distortions at the poles. Another alternative, the Winkel triple projection, is commonly used in educational contexts due to its balanced approach to area and shape distortion, providing a more accurate representation of the globe. In summary, the Mercator projection remains valuable for navigation and certain modern applications but has limitations when representing the entire globe. While it is still widely recognized and used in various contexts, The distortion of landmass sizes has led to the development of alternative projections, such as the Gall-Peters, Robinson, and Winkel triple projections. These alternatives provide a more balanced view of the world, addressing the Mercator projection's limitations and offering a more accurate global perspective. Thank you for watching. We have some amazing videos coming up, so stay tuned and make sure to hit the subscribe button.